Hey guys, Mr. Backerberg here. In this video, we're going to look at dividing square roots. So when we're looking at dividing some square roots, there's a couple different ways that we can approach this. And I'm going to show you both ways on this first example. So one way that we can look at doing this division is by simplifying down the radicals that we're working with first. So if we were to look at this square root of 32, I could make a factor tree here, and this is 16 times 2, 16 is 8 times 2, 8 is 4 times 2, and 4 is 2 times 2. So if I look for pairs in there, I have one pair of 2's, so I can take 1, 2 out. I have another pair of 2's, so I can take another 2 out. Remember, we have to multiply those together. But I have this last 2 that didn't get paired up with anything, so that's going to stay underneath my radical. Now, if I multiply that 2 times 2 together, I get 4 with the square root of 2, but this is still a fraction, and it's still being divided by the square root of 2. Now, when we're doing division with radicals in there, we can divide the numbers that are underneath the radicals. So because I have this square root of 2 on top and this square root of 2 on bottom, I can divide 2 by 2. So we get 4, and then I can do this division. 2 divided by 2 is 1, and that's going to stay underneath my radical. So I get the square root of 1. But the square root of 1 is just 1, so I get 4 times 1, and 4 times 1 is just 4. Now, I could have also done this problem without simplifying first. If we think about doing the division, since both of these numbers are underneath radicals, we can divide them. So 32 divided by 2 is 16, but because both of those were underneath a radical, my answer needs to go underneath a radical. And then 16 is actually a nice perfect square. The square root of 16 is just 4. So regardless of which way we approach this problem, we got the exact same answer of 4 each time. Now, if we look at this example with the square root of 15 divided by the square root of 3, we could try to simplify this down, but I don't think it's going to work. The only factors of 15 are 5 and 3, and that doesn't give us any pairs to simplify down. So we're going to have to think about this one the second way that we talked about. So because both of these numbers are underneath square roots, I can divide them. So 15 divided by 3 is 5. But because both of these numbers were underneath radicals, then I need to keep my answer underneath a radical. So I get the square root of 5 as my answer. Now looking at this next one, we've got the square root of 40 divided by the square root of 5. Again, we can try to simplify this down if we want to, or we can just look at doing the division with the radicals. I'm just going to do the division. If I take 40 and divide it by 5, I get 8 as my answer. But both of these numbers were underneath a radical, so I need to put my answer underneath a radical. But one thing that I should always do when I have a radical in my answer is check to see if it's simplifiable. So 8 we could make a factor tree for. That's 4 times 2, and 4 is 2 times 2. So I have a pair of 2's, so I can take the 2 out of the radical. But I have this other 2 that didn't get paired up, so it needs to stay underneath a radical. So the answer is 2 square root 2. Now sometimes as we're going through and working with fractions, we end up with a radical on the bottom of our fraction. And we don't like to have square roots on the bottom of our fraction. So we go through a process called rationalizing the denominator. So here we have this fraction 1 over the square root of 6, and we don't want to leave that square root of 6 on the bottom. So in order to rationalize this denominator, and that just means get the square root off of the bottom, in order to get rid of the square root of 6 on bottom, what we're going to do is multiply that exact same square root on top and on bottom. So on top, if I take 1 times the square root of 6, I get just the square root of 6. But on bottom, if I take the square root of 6 times the square root of 6, well, when I multiply radicals together, I'm supposed to multiply the numbers that are underneath the radical. So 6 times 6 is 36, but I keep the square root on my answer. Now 36 is a nice perfect square. When we square root 36, we get just plain 6 as our answer. But on top, we still have this square root of 6. Now, I'm not able to simplify this down at all because on top that 6 is underneath the square root, but on bottom that 6 is not. So I cannot simplify those down. So this is going to be my final answer. The square root of 6 divided by 6. So here we've got 1 over the square root of 3. We don't want to leave that square root of 3 on the bottom, so we're going to multiply top and bottom by the square root of 3. So on top, 1 times the square root of 3 is just the square root of 3. On bottom, when we take the square root of 3 times the square root of 3, we get the square root of 9. But on bottom, that square root of 9 just turns into a regular 3. And then on top, we still have the square root of 3. And again, just like we saw in the previous example, we can't simplify this down. This 3 on top is underneath the square root, but the 3 on bottom is not, so you are not allowed to simplify those down. Taking a look at this one, we've got 1 over the square root of 11. So to get that radical off of the bottom, we're going to multiply top and bottom by the square root of 11. On top, 1 times the square root of 11 is the square root of 11. On bottom, the square root of 11 times square root of 11. Well, if we notice what's happened, in our first example, we had the square root of 6 times the square root of 6. And at the end, after we simplified it down, we got just a plain 6. On the previous one, we took the square root of 3 times the square root of 3, did some simplifying, and just got 3 as our answer. I'm going to skip that middle step. When we take the square root of 11 times the square root of 11, that just turns into a regular 11. Those square roots kind of cancel each other out because we're multiplying it by itself. And once again, we're not allowed to simplify this down at all. This top 11 is underneath the square root. This bottom 11 is not, so we cannot simplify those down. Couple more examples with rationalizing, except now in the numerator we don't just have a 1. So in this one we've got 5 over the square root of 5. Again, we don't want to leave that square root on the bottom. So I'm going to multiply top and bottom by the square root of 5. So on top, 5 times the square root of 5. I can't actually multiply those together since this first 5 is not underneath a radical, but the second one is. So I'm just going to write it as 5 square root 5. Now on bottom, when I take the square root of 5 times the square root of 5, well, I would technically get the square root of 25, but the square root of 25 is just 5. So I have 5 root 5 divided by 5. Well, now if I look, the 5 on top and the 5 on bottom are both not underneath a radical, so we can actually divide those. And 5 divided by 5 is just 1. So we have 1 times the square root of 5, but having that 1 out in front isn't really necessary, so we can just write this as the square root of 5. Now this example is very similar, 7 over the square root of 7. I'm going to rationalize this by multiplying the square root of 7 on top and on bottom. So on top I get 7 times the square root of 7. On bottom, the square root of 7 times the square root of 7 is the square root of 49, but that's actually 7. Now if I look at these 7's on top and on bottom, they're both not underneath a radical, so we can divide them. 7 divided by 7 is 1 times that square root of 7. And again, I don't really need to have that 1 on it, so it's just the square root of 7. Now as I take a look at this one, I've got the square root of 2 divided by the square root of 21. And as I look at the fractions, I can't actually do any division with those fractions. But again, like we've been saying, we don't like to leave square roots on the bottom of our answers. So I'm going to rationalize this by multiplying top and bottom by the square root of 21. So on top, the square root of 2 times the square root of 21. Since both of those are underneath radicals, I can multiply them together. 2 times 21 is 42, and that needs to stay underneath my radical. And then on bottom, if I take the square root of 21 times the square root of 21, well, when you take a radical times itself, the answer you get is just the number that was underneath the radical. Now, we can't simplify down the 42 and the 21 because the 42 is underneath the radical and the 21 is not. But sometimes we might be able to simplify down our radical, so it's important to always check. 42 can be broken up into 6 times 7. 6 breaks down into 2 and 3. 7 doesn't break down at all. So as I look at this factor tree, there are no pairs, so that square root of 42 actually doesn't simplify. So we're just going to leave our answer as the square root of 42 over 21. In this example, we've got the square root of 5 divided by the square root of 6. Once again, we can't do any dividing with the 5 and the 6, but I see that we've got a square root on the bottom. So we're going to rationalize this by multiplying top and bottom by the square root of 6. On top, when I take the square root of 5 times the square root of 6, I'm going to get the square root of 30. And then on bottom, when I take the square root of 6 times the square root of 6, I just get 6. I cannot simplify down this fraction because the 30 is underneath the radical, but the 6 is not. I am going to check, though, to see if I can simplify down that 30. So 30 is 5 times 6. 6 is 2 times 3. I don't have any pairs here, so I cannot simplify down this radical. So it's just going to be the square root of 30 over 6 as our answer. Now, as I take a look at this example, I've got 3 over the square root of 14. I'm going to rationalize this by multiplying the square root of 14 on top and on bottom. 3 times the square root of 14 is 3 times the square root of 14. On bottom, the square root of 14 times the square root of 14 gives me just 14. Now what I notice here is that on top I have a number outside of a radical, and on bottom I have a number outside of a radical. Sometimes when this happens, we're going to be able to simplify down that portion of the fraction. But in this case, 3 and 14 don't have any common divisors, so this one doesn't simplify down at all. This is just our answer. Now as I look at this example, 8 over the square root of 10, if I rationalize this one by multiplying top and bottom by the square root of 10, on top, 8 times the square root of 10 is 8 times the square root of 10. On bottom, the square root of 10 times the square root of 10 gives me just a regular 10. Now, if I look at this 8 and this 10, there is some simplifying that I can do here. 8 and 10 are both even numbers, so these can both be divided by 2. So 8 divided by 2 is 4. 10 divided by 2 is 5, but I still have that square root of 10 on the top of my fraction. I didn't do anything with that. So this is going to be my final answer this time. 4 square root of 10 over 5. Now as I look at this example, we've got 6 over the square root of 12. I'm going to multiply top and bottom by the square root of 12 in order to rationalize that. So on top I get 6 root 12. On bottom I get just a regular 12. Now if I look, 6 and 12 have a common divisor of 6, so I can reduce that down. On top, 6 divided by 6 is just going to be 1. On bottom, 12 divided by 6 is going to be 2, but I have that square root of 12 on top. Now, we haven't run into this yet, but we might be able to simplify down our radicals still. So if I look, 12 breaks down into 4 times 3. 4 breaks down into 2 times 2. So I've actually got a pair of 2's that I can pull out of this radical. So I've got the 1 on the top of the fraction. I can pull a 2 out. I need to multiply those together. But then I have this 3 that didn't get paired up with anything, so it's going to stay underneath my radical. And the denominator of my fraction is still 2. Now if we look at what's going on here, if we multiply the top of this fraction together, 1 times 2 is just going to give me 2 with that square root of 3, but I still have 2 on bottom. And now I can actually do more division. 2 divided by 2 is just 1, but I still have that square root of 3. Because we have 1 times the square root of 3, I don't really need to keep the 1 on it, so my final answer in this case is just going to be the square root of 3. That's going to be it for this video. Thanks for watching.